Hey guys, this is Mr. Oliver. I'm going to go over the free response solution for Unit 2 for AP Physics C, and this will be the second question. All right, let's go ahead and get started. So on this question, we've got a system of blocks, pulleys, a frictionless table. That's really important that it's on a level horizontal surface of negligible friction, and there is some friction between blocks A and B, and it's stated in the problem statement. So for the first question, what we want to do is draw free body diagrams. So once again, free body diagrams, you'll see them once, you'll see them forever again. For block A, it's really pretty straightforward. You've got this picture, and so you can see right here that you're obviously going to have a force of gravity going down. That's obvious, you always have that. So you have a force of gravity going down. You're going to have a normal force pushing up, supports it. You're going to have this string right here pulling it to the left. There's tension in the string to the left. So I'm going to call that string number 1. So I'm going to call that tension 1. All right. And then there's going to be some friction down here at the surface, the interface between B and A. So if you're pulling it to the left, you can assume that the friction will be pointing to the right. Okay, so that's for block A. And then for block B, do the same thing, draw the free body diagram. And guys, it's real specific. It goes in and talks about all these specific little details. It's trying to tell you exactly how they want it. They want the arrow starting on the dot, pointing away from the dot. Don't have components. Don't draw like, horizontal, vertical components of any angled forces, nothing like that. All this is doing, if they just said draw a free body diagram, I think most of you would get it. But just be aware whenever it starts going rambling on, don't freak out about it. They're just saying draw a free body diagram. All right, so for block B, that's this guy up here, obviously you're going to have a force of gravity. Let's see if I can get this in the frame here. There we go. So you're going to have a force of gravity down, just like usual. You're also going to have some kind of a normal force pushing up from the table. All right. Now you're also going to have this block A pushing down on top of it. So you're going to have another downward force from the weight of block A. So I'm going to call this smaller one FGA and the bigger one FGB because we're referring to two different forces of gravity acting on it. Now, if you look here, there's tension in the string to the right, and so I'll call that tension number 2. And then you've also got string number 1 also pulling, but it's pulling to the left, and that's tension number 1. And there's actually one more force, and that's going to be the friction between block A and block B. And so you got to say, well, which way is that friction pointing? Well, if you think about it, if this block C pulls down, it's going to pull block B to the right, and block B moving to the right will in turn pull block A to the left. So these two blocks are kind of going like this. They're wanting to come apart from each other. So that means that block B will have this block A sliding across the top and exerting a force to the left of friction. All right. Now for question A, I guess this is AI. This one right here, this earned you 2 points plus 2, and then for double I, this is worth plus 3. All right, 1 for the vertical forces, 1 for the tensions, tension 1 and tension 2, and then 1 for the friction. Okay. Now question B asks to derive an expression for the maximum value of mass C at which the blocks will remain at rest. Express all algebraic answers in terms of all those variables that they give you: mu S, mu K, mass A, mass B, mass C, and physical constants. So this is a little tricky, but I think if you just kind of follow along what the free body diagram tells you, you'll be okay. So for this part, let's start off like this. The system is going to remain at rest. So that means that the force of gravity pulling down on block C, so if I look at block C right here, the force of gravity pulling down on block C, mc times g, has to be equal to all the other forces of all the other stuff on block A and B combined, right? So if here's B, here's A, then this force has to be balanced by all of this stuff, right? To remain at rest, this pulling down force has to equal all this. Well, obviously the up and down forces don't really contribute to side-to-side motion, so I'm not even going to look at that. I'm only going to look at the horizontal forces acting on the system. Okay, so if I look at B, let's look at block B down up here. So if I were to draw a net force equation on block B, I'm going to have a tension force to the right. I'm going to have a tension force to the left, so that's tension 1, and it's negative because it goes left, as well as some frictional force. And because block E is stationary, then that means that these three forces have to be 0. So therefore, let me take this equation and solve for T2. So move the tension 1 and the friction over to the right-hand side. So tension 2 is equal to tension 1 plus the friction. Okay, so if I look at block A, then that friction has to be the same as this friction, correct? Okay, so that means that tension 1, what I can do from looking at free body diagram of A, is that tension 1 and friction have to be equal, correct? Because block A is not moving either. So tension 1 has to be equal to the friction. Well, that's kind of cool because now I have two variables that I can make substitutions on. Okay, so what I'm going to do is I'm going to leave the friction terms in there, and so all I'm going to do is we're going to replace T1 with the friction. So tension 2 is equal to F plus F, which is just going to be 2F. Okay, so this is going to be important here in a second. Well, if I look back at block C is being held up by a string in the picture, and that's string number 2. So that means that tension 2, which is pulling on block C, is the same as tension 2 pulling on block B. All right, so I'll make that substitution that says tension 2 is mc times g, mass of C times g. And that has to equal 2 times the friction. Okay, so now the last thing I need to do is figure out what the friction is. So I'm going to come down here. I'm going to do this in a different color so we don't get confused. Friction is mu times Fn. That's just kind of in general. And because we're in a static scenario, nothing's happening, this is mu s. And so the friction, I can really look at it in any circumstance. So let's just look at the friction acting on block A. That's easy enough. So the friction is going to come from mu s times the normal force acting on block A. Well, that's just going to be ma times g. And so there's my expression for friction. So what I'll do is I'll make that substitution right here for my friction, and that's going to leave me with mc times g is equal to 2 times our friction, which is mu s ma times g. All right, and that is going to allow us to cancel the c's, or the g's, I'm sorry, and so mc is 2 mu s ma. And that's your answer. Now, you could have done this another way. You could have found friction in terms of free body diagram for block B. done a similar thing. It'd have been a lot more algebra, but ultimately you would have come to the same solution right here. Okay, so for part B, I cannot remember the number of points. Let me see what that is real quick. So for block B, that is worth 3 points. Plus 3. So we're up to 5, 6, 7, 8 points. So we're about halfway there. All right. Question number C kind of moves into an experiment kind of problem. And so what we're going to be doing on block C is, or part C, it says draw best fit line to the data above. All right, so they give you a graph. That's pretty nice. And their data points are somewhere around here, something like that. And so when it says the draw best fit line, make sure you have a ruler, guys. So super easy, draw your best fit line. Make sure you have like roughly half the data points above and half below the line. And you'll have something like that. So that's just 1 point to draw your best fit line. And now the second question says use the best fit line to calculate experimental value for G. All right, so how do we do this? Well, if I look at this new system where I've got this block B with some clay on top of it, and it goes over a pulley, and this system has some kind of acceleration. Well, it tells us what that is. It tells us that AC in the problem statement right here is mcg over m total. Okay, so let me rearrange this a little bit. Our acceleration is mc divided by m total times g. All right, so all I need to do is rearrange this and solve for g. And so g is AC over mc times m total. And the reason why I arranged it like that is because my graph, it gives us the acceleration AC, and it also gives us mc. So if I looked at this, the slope of this line, which would be the rise over 1, would be AC over mc. It'd be delta A over delta M, but that's the idea. And so this term right here, this is my slope. AC over MC is my slope. So to find G, all I need to do is take the slope of that line and multiply it by my total mass. All right. So easy enough to take the slope of a line. Just pick 2 points that do not include the data points. So somewhere on your line, choose 2 points and take the slope, the rise over the run. And so when I did this, I ended up getting a slope of somewhere around like 2. Okay, so like I said, just kind of manually doing it. Like I said, I ended up getting a slope around 2. And then the total mass is 5 kilograms from the data on the problem statement. And so you end up getting 10 meters per second squared. And so for that part CII, that's going to be plus 3 points. And guys, just remember, if you're given any kind of a question with a graph and plotting points, drawing lines of best fit, chances are you need to take the slope. I hardly ever see a question where you don't take the slope to get some kind of information. All right. Question D asks, if the mass of the pulley in part C is significant, would the experimental value of G be greater than, less than, or equal to? Well, if I look at my equation, I've got this AC over MC term, that's my slope, times my mass total. Well, what's going to happen if you have a heavy pulley, then that's going to add extra inertia into your system. And extra inertia just means that your acceleration AC would go down, right? Extra inertia would make this acceleration be less than the experimental value. All right, so that means that my graph, if I were to do that, if I were to include the mass of the pulley, and I looked at that, then if this is my original slope, my new slope would be a little bit less because of that value. All right. Now, what that'll mean is that your experimental value will be less than if that pulley was heavy than it was before. All right. Adding that extra rotational inertia makes that measured acceleration a little bit less than what you should get. And then the last part of the problem says a different group of students repeats the experiment, but instead of moving clay from block B to block C, they just remove a small amount of clay from block B and set it aside. So what they're doing is they're taking mass away from the system. They're making the whole thing lighter. And so the equation still applies to the new experiment. So for part D or part E, still doing the same thing, still the same equation, AC is equal to MC times G over M total. All right, so M total includes the mass of that clay, right? So MC doesn't change. So this term is constant this time. Before it was changing, but this time it's not. And of course G doesn't change. So what has to happen is that if the mass total gets less, what has to happen to the acceleration? Well, the acceleration will go up. So now what the question is, what are we going to graph? Well, I don't want to graph anything that has a constant in it. So I can't include the mass of the block C, and I can't include G. But I can include a total mass term, right? So what I'm going to choose out of this list is I'm going to choose anything that has mass total in it. And it's got to be on the bottom of the equation, right? So I'm going to choose something that has AC is equal to 1 over mass total somewhere in the bottom. So that's going to be, well, that's going to be choice, this choice right here, AC versus 1 over mass total. And also AC versus MC over mass total. Okay. So as long as I have my mass total term in the bottom on the right hand side of the equation and AC on the left hand side, in other words AC versus something with mass total down here, I think I'll be good. And so there's actually two of them that work. Okay. In other words, you got to have the total mass being the independent variable. It's got to be on the bottom. Okay, so that's the solution for the second question. If you have any issues, still need some clarification, just shoot me an email. Thanks a lot, guys. Bye-bye.